Welcome to Weathered Questions, where we answer the questions on your radar.
Welcome into another episode here of Weathered Questions, where we answer the questions on your radar. It's all about what's on your mind, and maybe you just came up with one right now, or maybe you've had one in your back pocket and you've been afraid to ask. Please ask it. We'd be happy to answer any question that's on your mind. You can email us your questions to weatheredquestions@gmail.com to join in on the conversation. We are, if you think about it, 5 weeks till school starts.
There's going to be some people who are very mad that you just made them think about that, Kai. And some people who are very happy.
It might be 4, actually. I don't know anymore.
We're pretty close.
Because half the time kids are doing their own thing, or athletics and band and all that stuff, but back to school shopping, it's coming. It's coming.
Ooh.
You ready?
That's coming even faster.
Yes, it is. Yes, it is. But how are you today, Jan?
I am great. And now that you have me thinking about it, I'm thinking about shopping for office supplies, which is one of my favorite parts of, I don't have any kids. I'm not going back to school, but back to school for specifically all the fun office supplies. I'm excited for that. So
you like to organize, though. If you could organize
do.
Every kid's desk, you probably would do it.
Is there a job for that? If anybody's hiring, I'm in. You know where to find me. Weatheredquestions@gmail.com. Great for asking weather questions. Also great for your organizational needs.
Can you imagine if we get a question? Hey, we have pencils of 3 different lengths, and we've got a kid who loses one every day. What should we do?
Oh, well,
I
that's
challenge
another problem.
somebody to please throw in one organization question just for fun. We need to have this.
Just so we have it. Yeah, that'd be great. No, I'm doing great. How are you? Staying cool?
Good. Yeah. Absolutely. No question about it. We've got preparations ongoing here for a big bike ride across Iowa.
That's true.
So that's a big deal here for us. No question about that. Ragbri is what it's called for those that aren't listening in Iowa. And pretty much if you're along the Ragbri route, your city shuts down and those riders come through, and it's one big party when it happens. So it's usually a fun deal. The most days I've ever ridden were 3. But they were 3 really fun days. And I remember rolling into Washington, Iowa, and eating 3 pieces of pie back to back to back. I was exhausted.
One of the best parts of Ragbri, right? All the pie. There's pie everywhere. I mean, there's good food, there's good beverage, there's good.
It's fantastic.
All the fun. I've only ever done one day. I am a fair weather biker. I love biking, but I also love knowing that there is air conditioning and a comfortable bed at the end of it.
Hopefully an air mattress, at least. Sleeping on the ground is rough, for sure.
Well, as we prepare for that, a lot of folks who will be maybe sleeping on an air mattress in the middle of a cornfield, curious about what the weather is going to be like for us as we head toward that. And today's first question comes in from Derek, and he asks, he says, I've heard meteorologists look at a radar image and say it's not actually reaching the ground. How do you know?
Well, that's a great question. In theory, if the meteorologist is saying that one way or the other, hopefully they've looked at least at a few things. Number one, they look at the airport observations to see if we've had any ground truth or anything that's occurred near the ground. Because what happens is, as you go away from a radar, you pick stuff up higher up in the atmosphere. It's 2 reasons. Number one, the beam is actually tilted from the radar site, so it goes up at about a 1/2 degree tilt. And so over time, the beam goes higher, but also the Earth is curved. And so as you get farther away from the radar site, it curves away from you. So you might be 5 or 6,000 feet off the ground by the time you see that radar detection. And if there's a shower up there, those little raindrops have to fall all the way through a mile of air. If that air is really dry, we can use it by looking at some of the weather balloon data and seeing how big is my spread between my air temperature and my dew point, which we talked all about last episode again. So if you need to hit rewind and hit 5.6, we talk about dew point again. But a large spread in that, we actually call that a dew point depression. And the larger that spread, the drier the surface air is, meaning it's kind of like if you were to stand on a footstool and take a really fine spray bottle of water and just spritz it. See if any of those little drops hit the ground. In the wintertime, I bet you they don't. A lot of them will evaporate before they get to your kitchen floor. Same thing in the atmosphere. If you've got something maintaining it, though, then those drops will make it down to the ground. That's a big thing. Look at your airports, look at your weather balloons, and then any sort of spotter reports that you might have. It's always a possibility that the meteorologist is just guessing. I hope we're beyond that in 2026, but you never know. The other thing, too, in the wintertime, road reports.
Yep.
If you're seeing a little blip of precipitation and you're wondering if it's touching the ground, you might pull up a webcam. There's webcams everywhere nowadays. When I first started in the business, we only had 3 or 4, and that wasn't even one per county. Now you can go almost anywhere and see webcams. And here's a trick for folks that have a webcam. If you point your camera in the direction of the wind, and if there's really small drops, those drops are going to hit your dome on the windward side of the storm. So that's why our cameras at work, Jan, would always ice up, usually from the east first when we had an ice storm, because all those raindrops would hit the east side of the domes, and you'd have to flip the camera around, and then it would switch to the west, and all of a sudden you've got no views anywhere because everybody's iced in. But those are the tricks of the trade that I would use. Anything that I missed, do you think?
No, I think you got most of it. That beam height is definitely one of them where, if you're looking at stuff, and if it's hard to picture this, like think of if you have a globe or something circular, it can be a bowl, I guess, and you put something straight on it, a ruler or a pen, right? Like very quickly, that straight object gets further and further away from that curved object. So if you're having a hard time picturing why the radar beam gets further away from the earth as it gets further away from the radar, hopefully that helps you kind of picture it a little bit, that there's just more distance for all of that precipitation to fall through. And then, looking at all of our station observations, those automated weather stations, the actual spotters, webcams, all of those things. Yeah, I think you hit it pretty nail on the head. I don't know if we missed too much there, but there's a lot of different things that we can look at to help kind of, triangulate, is anything actually happening or not? Or, for some meteorologists as well, depending on what part of the area that you are reporting on, if it's where you are, the good old window, also a really good tool.
Yeah, exactly. And now in this day and age, it's almost impossible to go without some sort of technology. So somebody's looking at something somewhere.
Yeah.
But yeah, the good old window never fails either. One more quick note about radar. Unless you use, now there's tons of weather apps out there. If you're using a common television station app, there's a good chance when you look at radar, it's going to look a little worse than what's actually falling on you. And there's a reason for that. That is called composite reflectivity. That's a mesh of all the radars in the country put together. And what composite does is, let's say you have a shower there at 5,000 feet, and then it's a little bit heavier at 8,000 feet. It's just going to plop that heavy spot, and it won't tell you how high up it is. It's going to tell you where it is. What composite does is it picks up the highest reflectivity or the brightest color anywhere in the storm or shower and plots it at the ground. It gives you a good worst case scenario of what might be coming. But I just want you to be aware of that, because if one of your friends uses maybe a paid app like Radar Scope or Radar Omega or one of those two, the radar may look totally different if you're using one radar versus the composite mesh like that. So just a heads up for those with outdoor events.
If you're not sure if you have a composite or not, I'm going to hazard a guess that you're using composite.
Yep.
And chances are, if you're using like whatever weather app came with your phone, or again, to Kai's point, generally most TV station weather apps or just those common free weather apps, they're probably going to be composite. And it's because that's the free stuff. It is, National Weather Service radar is free for everybody. And so,
and it's coarse.
If somebody came up with a color table and they made it look their own, but it's still the same data, and it is probably composite.
Yeah, it takes a lot less resources too on your system. It's a lot more coarse. You'll see it's kind of blocky and circly, and sometimes you'll see a little blip over you and it's not even doing anything. It might just be a little smoothing thing going on. So just heads up for all that are out there.
It is still a great tool. Don't get us wrong.
Oh yeah. It actually, it shows you more. than the others.
To the untrained eye, you may be missing a few things that would be that a meteorologist may see otherwise.
Yep, exactly. Speaking of meteorology, now we're kind of getting in towards some severe weather stuff again. And this is one we're talking about in terms of tornadoes because spring is a big tornado season. Sometimes we see a lull where we kind of get the doldrums of summer going, and then the fall, it usually comes back again. Mm-hmm. So there is that thing called a second season. So as we kind of talk about this situation, this question comes in from Jenny in Des Moines. We'll preface this with, this is a discussion. This is not end-all, be-all advice. Everything is going to be different in every situation, but we're just going to discuss what Jenny has to bring to the table here. Jenny says, we're in a trailer home. Where is the safest place to go in a tornado situation? There is a patio under the deck. Jan, what would you tell Jenny in that situation?
I would say get out of a trailer home. That is, it may seem counterintuitive, but one of the worst places that you can be in the event of a tornado or high winds, even if it's not actually a true tornado, spinning winds, even if it's straight line winds, one of the worst places to be is a mobile home or a trailer home or a structure that is not on a secure foundation. Mm-hmm. So that is exactly what I would say is don't be there.
Right.
And again, it may seem counterintuitive of, well, I have either this trailer home, this structure, this mobile home, or I can go outside into I don't know what. But generally, if you can, first preference would be don't put yourself in that situation. Don't be in somewhere that you don't have another option or a more stable option when there is potential for severe weather. However, if you have put yourself in that situation, the best bet is to, again, try to get out and get somewhere where you can have a foundation. Maybe that is a neighbor's house. Maybe that is, it's not a preference necessarily, but even like a gas station or a convenience store or something like that, that again has a foundation at least, even if they don't have a basement, that would be better off. As always with anything, a basement or cellar or something is going to be the most preferable, but we recognize that that's just not always possible. If none of those are options, maybe you're out in the country and there's just, no town or no nothing else around. If you can get down into a lower lying area like a ditch, that is also going to be a better option for you. Which again, it feels counterintuitive to say that. But it's just not trailer homes are just, they're not a good or safe place. They can easily get tossed around. And I say tossed around and literally tossed around. I mean, like a tornado is just going to toss it around like it's nothing. And that's why you don't want to be in there. So,
yep. One thing also that I specifically remember, this was years ago, when somebody called the TV station and they asked a question that I had never been asked before. Okay. And a lot of people wonder when tornado watches come out, when does it start? When are you expecting rain to hit? This individual asked, when does the tornado watch expire? And I thought to myself, well, I'll check for you. Hang on. Mm-hmm. So I said, 10 o'clock is the official expiration, but weather might be out a little bit sooner than that. She goes, great. I'll go stay with my mom, I believe she said, or a family member. Yeah. She lived in a trailer and was trying to get ahead of it and didn't want to be in the trailer and knew that it was either her parents or her mom, maybe one of the two, and wanted to know, when is it going to be safe for me to return back because I'm going to go ahead and get out of there. And that was her way of dealing with it.
Exactly. Being proactive.
Yep. And so the watch came out. We talked a little bit and I don't recall any major weather with that watch. So I'm assuming everything was fine. We didn't hear anything about it. There was no tornado in the area at all with any of the storms that I can recall. But then it left and I'm guessing she went back to her trailer and everything was fine. But that's an example of what you just said.
That's a perfect use of it though. I mean, that's why why the watch warning system is the way it is. It's to give people extra time. It's not meant to say, oh, yeah, that might happen, and then I'm going to wait until the warning comes out and only have 2 minutes to react. The reason that watches happen is so that you are aware, and if you need to take those extra precautions, you have the time to do so. And we recognize that may be an inconvenience, that, it's
absolutely
not something that you want to have to do, but that's why they exist.
Yep. And when an event starts, immediately the mindset has shifted now from, I've been waiting all day for this to start. Now it's starting. When is it going to end?
Mm-hmm.
And that was a great example, but that person was mature enough to get ahead of it before even a storm cloud had formed. I was surprised. I mean, it really caught me off guard because normally I don't care about expiration time. I never have. There's no reason for us to in the office. No, let me correct that. It means we can go home at 1 a.m. or midnight, whatever the watch is out, or 2 a.m.
Yeah. Yep.
That's all I ever cared about with it. I never even thought about something.
See, this
like
is
that.
coming from you as the morning Met who just had to come in early. Whereas those of us, like you said, like staying until 2 or 3 a.m., we're very concerned about the end time.
Yep. I'm sitting there going, I'm tired anyway. Just get me to Friday night. I can go to bed. That's where we go.
All right. Well, we're going to stay on the train of strong storms for today's trivia question. Today's trivia question, multiple choice. The change in wind direction as you move upward through the atmosphere is known as A, directional shear, B, helicity, C, speed shear, or D, vorticity. Again, the change in wind direction as you move upward through the atmosphere is known as directional shear, helicity, speed shear, or vorticity. We'll give you a few seconds to think on that, and Kyle will be back with the answer in just a minute.
Alrighty, maybe you've got it narrowed down, maybe you don't. Maybe you're wondering why Jan just punished you with all those big words. Well, here's the good part about meteorology is we do try and keep things logical. We try and color warm temperatures in warm colors. We try and color cool temperatures in cool colors. And Jan gave away a word in this. The change in wind direction. Hey, those are big words. Those are like second-year college words for some people.
No, this is
They're
fancy
big words.
stuff. But we did bury a little Easter egg in there.
Yeah, the answer is A, directional shear. And that's very important for rotating storms. And that's the type that we deal with when we deal with tornadoes. The other one, speed shear, is important for developing a thunderstorm in general because think of it as a garden hose. If you've got the water coming back down on itself and it's not tilted, the storm has a really hard time growing and maintaining over a distance. So speed is when the winds are the same direction or similar and they speed up as you go up. Directional is usually a 90 to 180 degree change as you go up. And in a tornadic situation in North America, normally an east-southeast or south wind at the surface causes you most problems. And then all you have to do sometimes is get 500 or 1,000 feet off the ground and quickly the wind turns to the southwest. And now you've got yourself a spinning storm, a spinning updraft. So that's where directional shear comes in. And that's why we can have rotating thunderstorms. And that is what leads us down the path of this question, which has to do with tornadoes. And this is another one that could turn into its own show, but I realize that we're short on time.
We'll try to keep it concise.
The question. Why can we get tornadoes in the morning and nighttime? True. But they are rarely long track or long lived. Jan,
it's a great question.
Thoughts on that?
So yeah, I like this one because it makes you think a little bit, right? What do we have when we normally get those big monstrous tornadoes that we don't have in the morning or the nighttime? And again, caveat to all of this, as Kai noted, we can get those. Tornadoes can happen at any time of day. But what we don't have overnight or what we don't have in the early morning hours is a lot of warmth from the sun, basically daytime heating, solar heating. So we lose one of our big ingredients generally after sunset. and through the nighttime hours that is key to producing tornadoes. Because as we've talked about before, as we all know, sun makes things warm, sun heats the earth heats the air around it. All of that kind of combines together, helps us get our really strong storms. Now, we can get those storms, though, in the overnight hours. Again, to Kai's point, we could commit an entire episode and then some to this, but short synopsis is we can get those tornadoes due to something called the low-level jet. And that basically kind of replaces almost that daytime heating. It brings in warm, moist air, and helps out with the speed shear, as well, the wind shear. So we can get all of that to happen during the overnight hours and kind of fill in those ingredients. That's the really quick Spark Notes version that I will not spend 30 minutes on.
Yep. And if there's any part of the country, statistically favored to actually have that happen, which again is not overly common, the Southeast U.S. is a spot. The Southeast U.S. in the winter. And it's because of what you just noted. Because if you've got a low pressure system spiraling through in the wintertime, you don't need that much instability to kick off a pretty good storm in the winter because it's so cold above your head. Once that warm air gets lifted, it's off to the races. And so that's a key difference between a summer tornado and a wintertime one, which the Southeast U.S. can get some nasty ones in the overnights down there. I think about that Mayfield, Kentucky one. And there's been several big Kentucky ones that have happened, in the darkness. And that kind of causes more issues when you have that. But up in our neck of the woods, it's very uncommon just because the ingredients are not there to sustain the actual tornado. It's there to kind of, it's almost like, you got a sparkler going, but you can't get the big firework to go. You need more gas for that. So the Southeast U.S. being close to the Gulf like they are can maintain that moisture supply a whole lot better than we can, especially in the cold season.
Yeah,
so
absolutely.
It's a good question. Definitely.
It is. It's a great question. Another good question coming in the last couple of minutes here from Lori in West Des Moines. It's a two-parter. I'll say them both and then you can dive in, Kai. So she asks, why do tornadoes turn counterclockwise? And what about twin tornadoes? Why does one usually go the opposite way?
Well, I can definitely address the first one. I am unsure about the second one. I don't know if they actually do that or not, if there are two. But the first aspect is probably the Coriolis force of the Earth causing that up where we are, because that causes a spin in the northern hemisphere. And it's going to cause the differences between the pressure gradient force and the Coriolis force. That difference causes things to spin largely counterclockwise in a low pressure situation, which is what the center of a tornado is. In fact, it's an extremely localized lower pressure system. And so when the air is flowing in that quickly into something like that, you're going to see more of a counterclockwise spin. And again, I think it's 99% of the tornadoes do that. Sometimes you'll get one that is got a different gradient going and it spins the opposite direction for whatever reason. But many of them are in that counterclockwise spin. To have two at once is rare to begin with. I think it was Pilger, Nebraska that had a twin, two EF4s
we had twins
going.
in Kyoto, EF4 and EF3 back in 23 as well.
Were they spinning the different direction though, or were they both the same?
I think so. I think they were opposites.
I wonder if it's just somehow the wind is just discharging, and if one is going this way, you've got an opposite and equal force going the other way.
I think what happens, and again, so I think we've said this multiple times before as well when we're talking about tornadoes. Tornadoes are still a very honestly unknown thing in meteorology, right? There is still a lot of questions, and that's why storm chasing is such a big deal. There's so much research still happening around tornadoes. But I believe that the current going theory for the twin tornadoes is essentially when you have a single tornado, you have a rolling column of air that is horizontal. It's rolling horizontally. It gets tipped upward and stretched down, right? So then it's vertical. I think with the twin tornadoes, that rolling column of air almost gets split in half. So then you have basically two updrafts to rolling columns of air. But
That's all I can think of.
Because it's split in half,
Right.
Basically, think about if you took a marker or a popsicle or whatever thing you want to break in half, it's going in the opposite direction then, because there's two different, the ends both become the down end and the middle becomes the top end. So I think that's the going theory right now. But again, they're so rare that we don't have a lot of data points. We haven't been able to research them that much. And so we just don't have a lot to go off of right now.
Yeah, I think you're right. If you're going to have a twin situation, then one of them's got to be in the downdraft side of the storm. It has to be.
Mm-hmm.
Otherwise, you can't maintain, two right there. So if it's going down the down, that sounded like a song or something. If it's going down the downdraft and there's some type of wind interference there, yeah, it may spin the opposite direction. But, how long do those things live? I don't know, because it's kind of going against the grain if you think about it.
Yeah, exactly.
Gosh, it can't last very long when that happens, I wouldn't think. But that's the only physical explanation I can think of, is an equal and opposite force. What goes up comes down, and it may spin the other way at that point.
Yeah, exactly. And to your point about them being rare,
high going down.
Yeah, to your point about them being rare, I think it's like 2% maybe of tornadoes. That of all tornadoes that have a twin. So like they are very rare. And again, that's why it's so hard to answer that one. We just haven't been able, even if they do happen, maybe not quite as long lived, or, maybe don't have the right people in the right spot to do the research at that time. So or they are just tricky.
They're so rare. Our sample size is like a dozen.
Yeah, exactly.
Imagine if you tried to do like a massive research project and, oh, by the way, here's 5 samples.
You'd be in grad school for a long time.
30 years of data. You'd be at it forever, and everybody would question your results forever. So no, they're just very uncommon, but that's a great question. I honestly don't know.
Yeah. Well,
no, I'd have to research that.
We will hope for more to be researched in the wide open plains where nobody is impacted.
Yes.
Other than, again, just some grazing fields, and we can get you a better answer hopefully soon, Lori.
Wide open views of the mountainside, and then it's really hot on the other side.
Yep, exactly. All right. Well, that brings us to the end of another Weathered Questions episode. Thank you so much to everybody who asked questions today. If you have one of your own that you would like to ask, feel free to write in. weatheredquestions@gmail.com is how you can get your question to be part of the conversation. We would love to have it. Don't forget to subscribe and tell your friends and family. We would love to have more weather geeks along for the ride with us. Until next week, stay safe.